Hello, I would like to show you how to access IO-Link device service data from a PLC. I have already prepared everything, so we can just start writing the program. I have already defined a main program, declared process data variables, found the connected IO-Link master, which is a 4-port master, and I linked the process data variable to the IO-Link device process data. So everything is already done, and we can start writing the program to access the service data of an IO-Link device. We are going to read two variables of the WL9 class, and these are quality of run and system state. So let us start with the quality of run. To read a variable out of an IO-Link device, I need to use the ADS read function block. And so I must declare an instance variable, which I will call read quality of run. And this variable is of type ADS read. It represents this function block. Then I need a variable which represents the value of quality of run, and I call it quality of run value. And now I need to know which data type it is. I can find this out in the IODD. So I'm just going to look in the IODD, quality of teach. I've got quality of run. This is the variable I would like to read, and I see bit length 8. So this means this is a byte. So I can use an integer type, and I see unsigned integers. I'm going to use this as well. Unsigned integer. And I also need a variable which I'm using to start reading, and I'm going to call it start reading quality of run, and this is a simple bool variable. Okay, now we can start to write the program. We have already declared all the variables we need, and now we call this function block, and we need to initialize it. First of all, I need the net ID, which is the address of the IO-Link master, and this is very easy to find it. I find it here. I copy it, and I paste it. As this is a string, I need to have this. Then I need the port number, and I know that the device is connected to the port 3 of the master, so I need to type in the port. And well, the port number is 1002. This is as the addressing of the port is a little bit different. It's 1000 for port 1, 1001 for port 2, and 1002 for port 3. Then the group index, it indicates the kind of SI-link communication, and for IO-Link, this is F302. So once you know it, you can use it always, doesn't change. And now the index offset is the index and the subindex of the variable, and we find it also in here. You see that the index is 175, and 175 is AF hex. So we put 00 AF 0000. So the first part is the index, and the second part is the subindex. We are reading the whole index, and I need the hex annotation. I'm expecting no more than 2 bytes, and now I need to tell which variable I'm writing the value to, and I need to make a pointer to it, and this is the quality of run value. So this is the pointer to the variable where we will find the value. I need the reading trigger, which is the start variable. The timeout is not so interesting, but I need these three variables as well. This is more for debugging purposes, but nevertheless. Busy. This is a bool variable. Error. This is also a bool variable. And then the error ID is a double word. This is defined by the ADS function block. And I need to put it here. Busy error and the error ID. Now the program is done and we can build it and check whether it works. Let us check whether everything is okay. So we first build the program and then we test it. We're building it and we've got one error which we can ignore. Now we transmit everything to the PLC. We start the PLC and now we just trigger the reading and we should see whether we can read the value. And we see, okay, the quality of run value is 99. So it looks like everything is done very well. As next, we are going to read the system state. So to do so, we need to declare another variable, which is an instance of the ADS function block. We already know it. And we call it read system state. And this is also a variable of ADS read type. Now we need a variable where we write the value into, which we called system state value. And now we need to know again which type is. So let us have a look into the IODD. I'm going to look for it. System state. So the system state is also a byte variable, and we see it's a record. So it's a complex variable, but nevertheless, we can use a byte. So let it be a byte. And we also need here a starting variable, which we call start reading system state. And this is again a bool variable. Okay, so the declaration is done. So we can now continue with our program and try to read the system state as well. I'm going to call my instance. I will need the same net ID as we are still on the same master, so I can just easily copy it, copy and paste it. It's the same port. It's still the same variable, the same device, and it's also the same index offset as we still are communicating IO link. So this did not change, but now we need the right index. So let us look up in the IODD for the index, and we see this is 226. And 226 is E2. So the index is hex 00 E2 and sub-index is 0. Length is, we expect 1 byte. The destination is pointer to our system state value variable. And we need also our reading trigger, which is this one. And just to save time, I am just using the same variables we already declared, which is busy, arrow, and arrow ID. This is not the best way to do it, but it is saving us time. So we're done. We can build to check whether everything's okay. We've got still the same error, which we can ignore, and now we can transmit this into the PLC with changes. And start the PLC. And when I now trigger the reading of the system state, start reading system state, I have a 0, I have no error, so it looks like it's okay, probably 0 is expected. To make sure that the 0 is the right value, we need to have a look back into the IODD just to understand this parameter. So when we have a look at it, we see that we've got a record, which is a complex data type, and it consists of two subindices, subindex 1 and subindex 2. And the subindex 1 is at the bit offset 1, which is bit 1, and the subindex 2 is at the bit offset 0, which means this is the bit 0 of this index. And now to understand what this subindices mean, we need to have a look at, for instance, this ID. Now we're just looking for this ID. And we see that this ID means no object detected when it's false, and it means object detected when it's true, right? And we go back to the system declaration. So we see that the subindex 2 false is TI 109 and TI 101 is when it's true. And when I look for this, I see object detected. So in order to test whether everything is right and we are receiving the right values, I can just put an object in between. And now when I'm reading this value, I would expect a 1, and it's a 1. So it looks like everything's right. When I just remove the object and I read again, I will expect 0 because there is no detection and there is a 0. So our program works and is fine. Having a PLC program, we for sure want this data to be read automatically. So to do so, we need to do a few more things. One is we need to check whether reading of quality of run is done before we read the system state. And then, of course, we want to wait for a while till we just restart reading of both variables. So to do so, we need first to declare two variables. One is the check for the reading of quality is done, and I'm going to call it read quality of run done. So this is the variable indicates that I'm ready with the reading of quality of done, and this is of the type falling trigger. And then I need a timer, which I'm going to call reading timer, and this is of the type tone. So this is our declaration. We can save it. Now we can start enhancing our PLC program. Let us start with the timer. So I'm calling the timer variable reading timer. It has an in variable which just starts the timer, and I say when the timer is not running, start it. So it means reading timer.q. So this is when it's not running, start it, and we are going to wait for a period of 1 second to restart the timer. Well, the timer is done. Now we need to check for the reading of quality of run is done. So reading quality of run done. And it has a clock variable which gets the busy of the read of quality of run. Run busy. Yes, that's it. And what we need to change to is the reading trigger, because we had these two variables, but indeed we don't really need them. So what we need here is the reading timer when it's time to read. Reading timer.q, and here we start to read when the first variable reading is done, and this is the clock. Reading quality of run done. .q. So now we are ready with the PLC program, and we can check it. Download it. Now we start a PLC program, and we see that the data is being read, and when I put an object in here or take it away, we see that things are running differently. I'm just going to teach here, and we see the value changing. Yes. So now we have a PLC program which is reading two different variables of just one device. One is of the type byte or unsigned short integer. The other is a record. What we did not do yet is we did not parse this system state variable. So we've got just one byte, but we do not really know what one and the other bit means. But we're not going to do it, as this is going to take too much time right now. Well, I hope it was a useful insight on how to access IO-Link service data from a PLC. Thank you for watching.